Today, we are diving headfirst into the world of data analysis. We're going to talk about how you can take a messy pile of raw data and turn it into clean, clear insights, all by using an incredibly powerful tool called Pandas. So let's get right into it.
You know that feeling, right? You've got this giant spreadsheet or some huge text file just staring back at you. It feels a bit like you're a detective with a massive pile of unsorted clues. You know the answers are hiding in there somewhere, but you just have no idea where to even start. It's a super common problem, but thankfully, there is a solution.
So here's our game plan for this explainer. First, we're going to bring some order to that chaos. Then, we'll get to know our main tool, what I like to call the super-powered spreadsheet. After that, we'll jump into our very first investigation, learn how to ask really specific questions, and finally, see how to pull all the different pieces together. Okay, let's get started. Section 1 is all about making that shift, right? Moving from that overwhelming feeling of data chaos to a place of, aha, I get it. And we're going to do that by introducing you to what might just become your new favorite tool. Say hello to Pandas, and no, not the animal. In the data world, Pandas is a software library for Python. The official description calls it a fast, powerful, and flexible tool, and it really is. But here's the bottom line. If you are working with data in Python, Pandas is your absolute go-to. It's essential. So how does Pandas actually, work? What's under the hood? In this next section, we're going to break down its two most important parts by thinking of the whole thing as a super-powered spreadsheet. The absolute star of the show in Pandas is something called the data frame. This is the main thing you'll be working with 99% of the time. Just think of it as your main case file. It's a two-dimensional table, with rows and columns, just like a spreadsheet. But as you're about to see, it is so much more powerful. And this slide really gets to the heart of it. With a regular spreadsheet, you're clicking, you're dragging, you're doing everything by hand, it's slow, and it's really hard to repeat your steps. A Pandas data frame, on the other hand, gives you total programmatic control. You can write simple code to handle enormous data sets and completely automate your analysis so it's perfectly reproducible every single time. So if a data frame is the whole spreadsheet, what are the individual columns made of? Well, in Pandas, each column is actually its own special thing called a series. The easiest way to think about it is just as a single, intelligent column, basically a list of data that has labels. This series is the fundamental building block of everything else. Okay, enough theory. Let's get our hands dirty with a real investigation. We're going to use a really famous data set, the passenger list from the Titanic. This is going to be our case file as we learn some of the basic, most useful commands. Now, the very first step for any data detective is to get the evidence into the lab. In Pandas, that's super easy. We use a function called read_CSV to load our file right into a data frame. Then, the first thing we almost always do is use the .head method, which just gives us a quick peek at the first 5 rows to make sure everything loaded in correctly. And boom, here's what we get. This is our first look inside the case file. We can immediately see our column headers. We've got passenger ID, whether they survived, their passenger class, name, sex, age, and a few others. The data is now perfectly organized in our data frame, and it's ready for us to investigate. Looking at just 5 rows is a good start, but we need a bird's eye view, a higher level summary. What kinds of clues are we actually dealing with here? For that, we use the .info method. It gives us a fantastic, concise summary of our entire data frame. This command is so useful. We can instantly see we have 891 entries, so 891 passengers. But wait, look closer. The age column only has 714 values, and cabin has just 204. That tells us right off the bat that we have missing data, and that's a huge clue in any investigation. We can also see all the different data types, like numbers and text. Okay, for our last piece of this initial sweep, let's get a feel for the actual numbers in our dataset. The describe method is perfect for this. It instantly calculates a bunch of key statistics for all of the numerical columns. And just check this out. With one simple command, we can see the average age of a passenger was about 29, almost 30 years old. The youngest was just a baby, and the oldest was 80. And look at the fare. Someone paid over £500 for a ticket, while the average was only 32. These are the kinds of stories you can start to uncover in just seconds. So, we've done our big picture overview. Now it's time to zoom in and get specific. In this section, we're going to learn how to slice and dice our data so we can ask very targeted questions. Let's start with a really simple question. Who were the youngest people on board the ship? We can find that out instantly by telling our data frame to sort itself using the values in the age column. The command for that, .sort_values, lets us reorder the whole table based on whatever column we're curious about. Now listen up, because this next concept is really, really important. How do we grab specific pieces of our data? Pandas gives us two main ways, ilock and lock. The key difference is how they find the data. ilock uses the integer position. It's like saying, give me row number 1 and column number 5. Lock, on the other hand, uses the actual labels, like saying, give me the rows with these index labels and specifically the name and age columns. It's all about position versus label. That's the main takeaway here.
But what if we want to create totally new information from the data we already have? Well, it's incredibly simple. Here, we're creating a new column called Age in 2026. All we have to do is define the calculation, and Pandas automatically applies it to the entire age column at once. You don't need to write any complicated loops or anything. It just works, adding a brand new clue to our case file.
So far, we've only been working with a single file. But in the real world, your clues are often spread across multiple reports, right? Our final section looks at exactly that, how to combine different tables of data. Pandas gives us two main ways to do this. First, there's concat, which is short for concatenate. This is perfect for just stacking tables, either on top of each other or side by side, kind of like adding new pages to your file. And then there's merge. Merge is more sophisticated. It combines tables by matching up data in a column they both share, just like a detective finding the same suspect's name in two different witness reports to link them together.
So let's just bring this all home. What we've really seen today is a fundamental shift in how you can interact with information. By learning just a few of these simple commands, you've gone from being a passive data spectator, just staring at a spreadsheet, to being an active data detective, someone who can actually interrogate your data and make it reveal its secrets.
And I think this quote from Carly Fiorina just sums it all up perfectly. Raw data by itself is pretty much just noise. The goal, and what tools like Pandas really empower you to do, is to first turn that noisy data into structured information, and then to analyze that information to uncover real actionable insight.
And that really just leaves us with one last question to think about. From public data sets you can find online, to information from your own job or your hobbies, data is literally everywhere. So, now that you have some of the tools of a data detective, what stories are you going to go out and uncover?